Under the fluorescent lights in the workshop, rows of unpainted J-35 aircraft emit a cold light, with the number 3557 on the green skin silently telling the rhythm of China's aviation industry's fierce fighting. In recent footage broadcasted by CCTV, the production line of the Shenyang Aircraft Corporation's J-35 fighter jet was fully exposed, with neatly arranged bodies presenting a green stealth coating on the position. One of the aircraft's 3,557 numbers on the body sparked heated discussions among military enthusiasts. This number has extraordinary significance. Looking back at the video of the Fujian ship-launching carrier-based aircraft previously announced by CCTV, it can be distinguished that the J-35 numbers are 3505 and 3506. The leap in numbers from 3503 to 3557 reveals that the J-35 has entered the full-speed production stage. The number 3,557 implies that at least 57 mass-produced models with practical capabilities have already been produced. Considering that military aircraft numbers are usually allocated by batch, the actual total production may have exceeded 60 aircraft. This production was achieved within about 30 days after the official announcement of the J-35 entering service, marking a historic breakthrough in China's stealth fighter production capacity. In the middle of the CCTV screen, the UDA's distributed electro-optical aperture system, which is clearly visible on the back of the 35 machine, becomes a highlight. This system forms a 360-degree field of view without blind spots by installing multiple infrared sensors distributed on the body. EUDS is not only used for air search target indication, but also for missile warning assistance, day and night navigation, and takeoff and landing collision prevention functions. More advanced is that the system can complement the radar warning device, enabling the fighter jet to achieve dual RF and infrared warning capabilities. The J-35 is also equipped with an EOTS electro-optical aiming system below the nose, which integrates infrared optical laser irradiation mode and has a complete set of electro-optical fire control functions such as high-resolution imaging, automatic tracking, infrared search and tracking. The comprehensive deployment of these two systems has enabled the J-35 to rank among the top tier in the world in terms of situational awareness capability. One of the key factors for the J-35 to achieve large-scale production is the resolution of its heart problem. The WS-19 engine has entered the mass production stage, and this target class engine is fully benchmarked against the EJ-2000 engine of the European Typhoon fighter jet. Huang Weina, chief engineer of AVIC Guiyang Institute, revealed that the research and development of WS-19 has entered the material selection stage and may achieve mass production ahead of schedule. The development progress of the WS-19 has far exceeded expectations and is expected to become a new benchmark in the global mid-range promotion field. It not only meets the power requirements of the J-35, but also provides it with maneuverability beyond other fighter jets of the same class. Official data shows that the WS-19 engine has a maximum thrust of 12 tons and a total lifespan of 4,000 hours. Compared to the RD-93 engine equipped on the J-31, the maximum thrust and total lifespan have increased by 30% and 25%, respectively. The key to the rapid mass production of the J-35 lies in the application of advanced manufacturing processes. The J-35 pioneered the large-scale segmented modular manufacturing method during the research and development process, extensively using 3D printing additive manufacturing technology and new composite materials, achieving significant weight reduction and improving the performance of the fighter jet. Traditional fighter jet manufacturing uses hydraulic forming of the main structure, which can only manufacture the body interruption and wing structure separately. The final assembly process requires a large amount of riveting and welding. The additive manufacturing integrated molding process and 3D printing used in the J-35 can efficiently manufacture the entire main structure of the aircraft, achieving high pre-assembly rate and large segmented modularization. This technology was led by Wang Xiangming, Executive Deputy Chief Designer of the J-35, which pioneered the engineering application of additive components in aircraft. After applying this technology, the number of J-350 aircraft was reduced by 2/3, the structure was reduced by 1/5, and the fatigue life was increased by 1/3. The production capacity of the J-35 has increased at a faster rate than the US F-35 fighter jet. It took 5 years for the F-35 to go from mass production to annual output exceeding 100, 3 years for it to exceed 60 aircraft, and only about a year for the J-35 to reach the same output. This achievement is due to the comprehensive upgrade of Shenyang Aircraft Corporation's production line. It is reported that in the 280,000 square meter intelligent factory of Shenyang Aircraft Corporation, 4 pulsating production lines are operating at high speed, compressing the production cycle of J-35 to 72 hours. With 1 production line operating at full capacity, the annual production capacity of J-35 is expected to reach 150. By comparison, the total production of F-35 in 2023 is about 140 aircraft, of which only about 80 were obtained by the U.S. military. According to this trend, by 2026 and 2027, the annual production of the J-35 will exceed 100 aircraft, and with the J-20 already exceeding 100% annual production, China's average annual production of stealth aircraft will exceed 200 aircraft. Entering Shenyang Aircraft Corporation, a 280,000 square meter intelligent factory, 4 pulsating production lines are running at high speed, and the J-35 fuselage lifted by the robotic arm is circulating between different workstations. On the other end of the workshop, workers are installing the WS-19 engine for the latest J-35 fighter jet, which has entered mass production and completely solved the heart disease hazard of the fighter jet. While the world's attention is still focused on the J-20, China's aviation industry has quietly launched another fifth-generation aircraft production line. The mass production capability of the J-35 signifies that China's military manufacturing industry is no longer a breakthrough for individual fighter jets, but a comprehensive rise of the entire aviation industry system.